Tearing a string. A weight, 0.33 kilograms, hangs on a thin string, and underneath, with the same wire, hangs an identical weight. If we gently load another weight, the top wire will tear, but if we drop the weight from a sufficient height, the wire connecting the two weights will tear. We'll start with gentle loading and then fast loading. What is the explanation for this phenomenon? Want to say? You have a few seconds to stop the video, before moving on to the explanation. Two facts: A. The wire should lengthen slightly, like a spring, before tearing. B. When pulling a body with a spring, the wire also acts to some extent like a spring. The body's speed lags behind the puller's speed. The lag depends on the body mass and spring rigidity. It is difficult to notice these phenomena because of the small movements that occur during the tearing process. On the next page, we will lengthen and increase the process to discern the details. We'll play the slow loading video again. Note that during the fall the upper body moves towards the bottom as a result of the spring pull of the stretched wire. And now fast loading. Springs to extend the tearing process. First, we will activate the two processes one after the other, and we'll see that the springs make it possible to see the tearing process. First video, slow loading. Second video, fast loading. Now we will focus on the stages of tearing. With slow loading, the upper body moves slower than the lower one. But since it requires a much shorter movement than the lower one, it tears the wire first. When loading is fast and strong enough, the lower's body movement will be so fast that it will precede tearing the wire before the upper one can move the little required to tear. Slow loading. Fast loading. The springs, one step before tearing. We will activate now simultaneously, both processes magnifying them. We'll stop one step before tearing and compare the length of the springs.
Thanks for watching. Loved? Don't forget a like.